Okay. All right. Well, tonight's speaker is Jason Dickey, who's an aquatic ecologist and environmental consultant based out of Niskayuna. Um, Jason is one of our board members, and hopefully will leave everybody with a fascination of mussel ecology and their critical role in maintaining healthy waters. So with that, Jason, I'm going to let you share screen. And as he said, anybody feel free to unmute and ask questions as we go along.
All right. Are you seeing the black screen with my arm and a bunch of muscles on there?
Yep.
Cool. Uh, well, yeah, thanks for giving me the opportunity to speak and for lending me some time. I kind of feel like I'm on a mission to get everybody as excited about mussels as I am. I definitely like knowledge sharing on this topic. And my joke is that I can bore you for days on mussels if you let me, but here I've compacted it into about 40 slides. So uh, if you have questions, yeah, go ahead and just interject. This is a small group. We can definitely keep it informal, and we can have discussion around these slides as we go. We don't have to wait till the end. Um, so yeah, I guess without further ado, uh, I'll start by kind of introducing myself a little further. I currently work as an environmental consultant. I've been a consultant for about 20 years. Um, and here in my current role, I'm a project manager and a permit specialist, mostly working on a wide variety of energy infrastructure projects. Some of it's renewable, hydroelectric. There's been some oil and gas. There's electric transmission, substation, battery storage. So that's like my day to day, and it has absolutely nothing to do with fisheries. But if you go far enough back, my graduate degree was limnology at Auburn University. That's in southern Alabama. And limnology, if you're not familiar with the term, is it's the study of freshwater ecosystems. And I like to tell people that I'm basically a marine biologist, except for freshwater. Um, and that's the best way to explain it. But prior to grad school, I had spent a year working with the U.S. Fish and Wildlife Service in Panama City, Florida. That's when this picture was taken. I was mostly focused on movement, habitat use, research of this federally threatened Gulf sturgeon species. But it was during this year appointment that I was first exposed to and became interested in freshwater mussels. I kept that with me into grad school, and then it followed me into the consulting realm. I eventually got a highly coveted uh, federal permit to scientifically collect for species on the endangered species list. And it specifically includes the drainages on the northern Gulf of Mexico slope that go into Florida, Alabama, and range up into Georgia even. And there's only like maybe a dozen consultants even still that have that permit. And none of them live in Florida. uh, we moved up here from Tallahassee probably, I don't know, 13 years ago or so. But even since moving here, I would say I get regularly called down to Florida, but at a rate of about once a year, uh, to work on a mussel project. And for me, that's a fun moment to get out of this daily grind of permitting energy and go play in the water and kind of reconnect with what really got me excited about biology. Um, in fact, I had one of those requests come in last week, so I'll be flying down to Florida in April uh, to do a survey and a relocation for a Florida DOT project. Already looking forward to it. Um, but I've obviously worked on mussels in Georgia, Florida, and Alabama, but I've done mussel work in Texas, Missouri, all the way up to Michigan, here in New York. Just last month, we did a mussel survey for um, a marina dredge project on Chautauqua Lake, way out in Western New York. So, it feels like the opportunities are few and far between, but I rarely say no because I'm just passionate about it. It's my chance to go play. And talking about it like this is also a chance to go play. So we're going to start at the base, at the ground floor, and just make sure everybody's level set on what mussels we're talking about. This is what most people think about when they hear mussels, either that or the exotic invasive species like zebra mussel, quagga mussel. Um, so what my presentation here is a completely different realm of animals than the saltwater or than the exotic. I'm really specifically going to be talking about our native freshwater mollusks. They're out in our rivers and lakes and creeks. And to get it really technical, I'm going to mostly be focused on mussels that are in the order Unionidae. Um, they Unionidae are defined. They're I've got this here bivalve mussels. Bivalve just meaning two valves, two shells that close in a clam-like fashion with an obligate parasitic larval life stage. That's a mouthful, but it's worth breaking down. Obligate just means that it's a requirement of, they all share this characteristic that they actually serve as a parasite for a significant part of their life cycle when they're in the larval stage. That's part of mussel ecology that I think most people are not aware of, um, and find most surprising. And it's also, in my opinion, probably the most fascinating thing um, about mussel ecology. So I look forward to delving into that more in a few slides. But first, we'll just sort of take a step back and look at worldwide mussel diversity. There's about 840 species, recognized species across the globe. There's some ebb and flow to that as geneticists, you know, might maybe lump a couple species together based on genetic or split a couple apart. But and I think there's probably still a lot of sort of virgin water in East Asia that as they continue to study it more, I bet you that number will continue to climb. It's fairly static in North America, but at 302 species, we're second only to Eastern Asia. We have a lot here. Um, they're on every continent except for Antarctica. Um, Unionids make up about 80% of this. And I'll note that there are five other orders of mollusks. So I'm not really going to spend any time on them because we don't really have any of them in North America. We have one, Margatifera. It's represented by five species, but we're just going to stay focused on the unionids. So at about roughly 300 species in North America, um, most of that is east of the Great Divide, and the this is a heat map showing the level of imperilment status, but it closely tracks. It could just as easily be a biodiversity heat map. What you're seeing here with the more intensive colors is just the Appalachian Mountain Range, and that's where we have the highest biodiversity in North America. Um, we do have mussels occurring out west, California, Oregon, but a much lower number of species, single digits, whereas Alabama's got 175. So, and with the higher biodiversity comes the higher level of imperilment, which is what this is fish and mussels, but the two track. They track very well, and that's what we're seeing here is where the most at risk species are. Um, Overall, about 75% of our mussels in North America have some level of state or federal imperilment status. So to flip that, it means that only about a quarter of our mussel species are stable, have a stable, sustainable population. And the rest of them are just gradually marching towards extinction, some at a faster pace than others. Um, this is a zoom in on the eastern U.S. here, and these numbers are the number of species by state. I'm from East Tennessee originally and lived in Georgia for a period and went to school in Alabama. And those three states have the highest biodiversity for mussels. But up here in New York, 50 is not a shy number. But we are the periphery. And once you get further into New England, it drops precipitously back, into the low teens there. So we're kind of right on the edge. Um, there's a lot of explanations for that we can get into. I didn't plan on it, but you have to go pretty far back and geologic time to look at the glaciation and what that did for connecting or disconnecting water bodies. And at the same time, during the ice age, uh, when water sea level were lower, a lot of these rivers that stop at the shoreline continued out into what is now the Gulf of Mexico, and they actually connected. So it's kind of neat if you go far enough back and look at how there could have been immigration from one drainage to another, and how these things, how differently things were, hundreds of thousands of years ago. Um, the reason that I think Alabama kind of wins the prize for the highest diversity is in the northern half of the state. You've got this Appalachian influence. You've got a couple major river drainages, including the Tennessee River. But right around Auburn, right around here, is what they call the fall line. And it is a sort of a geologic boundary. You lose elevation pretty rapidly, and then you're in the coastal plain. And the coastal plain is like a whole different realm of habitat conditions in these rivers and streams, and a whole different assemblages of mussels and fish. And that those coastal plain species account for a lot. So Alabama kind of gets the best of both worlds. You don't get the same. The Savannah River does have unique species that are endemic just to that river, but here in Alabama, you've got uh, there's several major river drainages that are coming up here. Um, all right. So why do we care? To the layman, mussels are just little fuzzy brown rocks on the bottom of the river. There's actually six of them in this photo. And I don't know how well this photo shows up on your screens, but I'll leave it here for just a quick second. Maybe you see something that you think would be a mussel. Um, I see them right away. Just I'm immediately looking for these apertures. You've got the incurrent aperture there. They're siphoning the water in and then expelling it out. And that's their respiration. That's their feeding mechanism. So the six mussels are here. But once you get them out of the water and you brush off the river funk, um, oh well, actually, I'll come back to that thought. This was my tailgate experiment. This is another reason why should we care. I set this experiment up in Tallahassee years ago. I just got these two 10-gallon fish tanks, and I went to a nearby lake, and I got this turbid water, put the same water in both, and in the tank on the left, I put 10 of these. These are, the common name is the fat mucket. It's a very large, heavy-bodied mussel. I put 10 of them in this tank, and I put none in the other. And I was curious just to see, like, will 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 there be a visual effect here, and if so, like, how long is this? Something that's going to be on the order of days, like overnight, 24 hours? Might it take several days, a week? Could it go quicker? Really didn't know. um and this is they're pretty stacked in there. I mean, 10 mussels of this size and just less than 10 gallons of water, you don't really find that density out in nature. If you did, it'd be rare. But anyhow, I will revisit this slide, but I would ask you to just think about this for yourself. How many days, how many hours to see an effect, if any? Now the river funk. You get these out of the water and you brush them off. They're so amazing. It's just such a wide variety of colors and shapes and sizes. And some have ridges and corrugations, and some of them have rays. Some of them are big, they can weigh almost 5 pounds, and they live to be 60, 70 years old. And some of them at adulthood, like this little dude right here, toxoplasma, could live 15, 20 years and won't ever get any bigger than that. It's like an underwater Easter egg hunt. And what you're looking at here, this was from about an hour-long survey on the lower Flint River, just south of Albany, Georgia. It's just an hour with a few hands in the water, and this is what comes up. Um, it's really exciting, especially when you get something like this. This is a federally threatened species. It's called the purple bank climber. Even kind of has this purple sheen that's coming through in this photograph. And just awesome corrugations, those ridges. It just feels really neat in your hand. Um, Not to be confused with these. This is a washboard, and this is very common and stable throughout its range, all up the Mississippi River. But as much as they can be different, they can also look the same. And therein lies the problem. In my hand here, I have three different species. Two of them are federally endangered, and the third is common and stable in its range. And, you know, and so that this, because they're complicated, this limits the number of people that can effectively go out and sample for these and contribute to the conservation of the species. And also, I mean, frankly, it's not like I'm holding a sea turtle or a manatee. There's no charisma in my hand. And that also is a challenge to conservation because it's hard to get people excited about this, you know. But uh, earlier we talked about the obligate parasitic larval life stage, and we're going to move into that next. And this is where I'm going to hook you. Um, this is a gravid female mussel. The female mussel will move her eggs into these modified chambers of the gills. They'll sit there, and this female was fertilized by sheer dumb luck. Somewhere out in the mussel bed, you've got male mussels that are excreting their sperm just indiscriminately into the water column, and this female is just siphoning water for food and respiration, and encountering the sperm are fertilizing those eggs, and they're going to start to develop. And it doesn't take long for those fertilized eggs to become larval mussels. And the term for larval mussels is called Glaucidia. You'll see it spelled on the next slide, and I'll keep referring to it. But those Glaucidia here in the center, you see this sort of swollen pouch, and those are those gill chambers. Each one of these just loaded with thousands of Glaucidia and just ready to erupt. That's just a grenade. And when she's ready, she'll introduce those Glaucidia into the world, and that's where it gets really cool. Get my notes slide here. So most mussels, all unionids, rely on a fish host in order to complete their reproductive cycle. Starting at the bottom with this adult mussel and then working in a clockwise direction, the gravid female has to pass along her Glaucidia to the host fish. They attach onto this host fish, and the tissue on the fish actually will insist over the Glaucidia, and they'll live on that fish for a couple of months. And they're getting nutrition from this fish during that time. They're living as a parasite. It's benign parasitism. It doesn't really affect the fish. And then when they're ready, they let go and they fall off, and wherever they land, that's where they spend their days. They're pretty sessile creatures. I remember I was at a workshop at Ohio State University, and Dr. Tom Waters, who's passed away now, but kind of wrote the book on all the species in the Mississippi drainage. We're in one of those university auditorium classrooms, and I just like the way he put it. He said, for a mussel to move from one side of this room to the other would be an epic lifetime journey. So I I chuckled when he said it, and I like repeating it. It's true. They can move. This foot, this abductor, this muscle here, it's not abductor muscle, but this muscle, they can push it down, and they can do vertical movements, and they can go pretty deep. And they can also move side to side. But generally, they like to be up near the surface, just with about 80% of their shell in the substrate, and just enough poking out so that they can open and let those siphons do their work. And on the host fish, so not just any fish will do. Um, that relationship between the mussel and its fish host is species specific. It's not well understood why yet, but we know from laboratory studies that Glaucidia simply won't survive on the wrong fish species. Um, and believe it or not, there's a lot of mussels to still, like, where we don't even know for sure what their host fish species are. And I use species there both singularly and plural, because for some species it might just really be one fish. That's it. And others are more generalists. There could be 7, 8, 9, 10 fish that and again, the biochemical mechanism driving that is still getting teased apart at the university level. But um, if you think about it, you know if you're a mussel and you rely on some endangered darter as your fish host, and that darter is not doing so well, if you're in those southern Appalachian streams that they all got dammed up by Tennessee Valley Authority, or there was a coal strip mining operation, and with those darters go, you're done. You're not going to die immediately, but there's not going to be any recruitment. There's no babies. There's no next year's crop. So that linkage, as cool as it is a real liability, for a lot of mussel species. So this all hinges on that gravid female being able to infect the host fish, and the the methods that have evolved for that interaction are amazing. It's my favorite part. We get to move into it. Um, Again, this is that marsupial, that swollen pouch. It's all full. For this particular species, she has the ability to blast those out like little Glaucidia cannons out in the way. You'll see video of that here in a second. Um, but this I've circled in green. This is just mantle tissue right there at the opening of the clam, and it's pigmented. You see these pigments form striations, stripes, and it looks kind of similar to this little darter right there. Looks very similar, in fact. Um, and this has just occurred through. This is just evolution at its finest. And not only is this a visually convincing attractant, whatever's going to eat that little darter is going to come inspect this mussel as food as well. But this female mussel has the ability to kind of flick and flutter that tissue to mimic a fish. This isn't the same species, but this is the same strategy of the mantle display. The pigments on this even has eye spots. This is a grainy photo. Forgive me for that. But you can see she's working it. And in the middle of that flick, you see the swollen marsupial in there. I'll do that one more time. And so, those, like I said, those are Glaucidia cannons. They're ready to blast. Um, this is another strategy. This is Tychobranchus. We have this species in New York. This species packages those Glaucidia into these mucilaginous pouches and is able to project them outside of the shell. They're tethered with a little thin protein.
Mucilovaginous. Oh,
Um, they're tethered with a little protein strand, and they're outside of the shell, sort of doing their thing. Um, Close-ups of these, they also have pigmentation, and in this case, the pig what these actually are modified Glaucidia that they're will not really be viable to grow into a mussel. They're there just to make color on this little mucus package. This is called a conglutinate. Um, but that's pretty amazing stuff. If you took a little thin slice and looked at it under a microscope, you can actually see these individual Glaucidia. You see them with this hinge structure that is so inherent to a clam. They've got these teeth here. And that's the mechanism where they're able to really grasp onto that fish and stay there. And it's cool because there are identification keys. You can identify Glaucidia to species in a lot of cases, just based on the morphology of those teeth. And here, these are, I don't know if this is a crappie, some sort of fish. They're the gill. Those are particularly susceptible to the Glaucidia during an infection. And you can see where it's these little nodes. Those are Glaucidia that have latched on, and it's probably got a little thin layer of membrane to insist over it. And they're thriving and developing and stealing nutrition from that fish. got another video here. This is another mantle display, a much better quality. And you'll see a couple of largemouth bass come in to inspect, and she's working it. She's flipping, and when he comes in to take a bite, boom, she blasts those cannons, and it's just a cloud of glaucidia. I don't know if you can hear the audio, maybe not. Uh, but these are little largemouth bass. Boom. So this fish is coughing in this cloud of glaucidia, and they're all latching on right now. Anywhere they can, anything that's soft, they're latching on. And this is amazing footage here. You're actually seeing them snap on. Yeah. So that's 4 to 6 weeks usually on average. It can vary, and then they'll drop off and finish growing. Oh, this is a cool one. This is completely different. This is entrapment. This is the genus Epioplasma, which unfortunately is one of our more imperiled um our more imperiled species. But this sort of lures the fish into the shell and then closes on it and holds it there. And while that fish is in there trying to get out, it's just getting it. Let's see. So it's not going to kill the fish. It's going to hold it for a while. It's going to make sure that this fish is infected. And there's a little bit of a time lapse to this. You'll see as it fades into more advanced. You can see these glaucidia kind of foaming out of the shell, and this poor fish is just getting bathed in this stuff. Um, and then eventually it'll release him, and he swims on. Uh, what a cool strategy! There's so many others. There's I talked about the conglutinate. There's one called a super conglutinate where they package it into that sort of mucus stuff, but then send it on downstream. It has a little tether that will get hung up on a stick, and it'll just sit there and just kind of fish. And the mussels maybe hundreds of feet away. And those super conglutinates, I've seen those in the water during surveys before. They kind of just look like fish flesh. It looks like the kind of thing that a largemouth bass would go after, and that is the prime host fish for that particular species. Um, there's if you go out and elsewhere in the world, there's a lot of crazy strategies. There's one somewhere in Europe that actually climbs up out of the water, up the bank, and then sort of spits this arc of water with glaucidia, so that when that breaks the surface of the water, all the little minnows rush up to get it, and that's its method. There's species that we have here in the U.S. where they excrete this web of glaucidia for pelagic fish, schooling fish that would just swim through it and just encounter it that way. It's so many varieties, but for sure the most unbelievable and charismatic are the ones where their pigment looks like a fish. It's amazing. Okay, let's check in. This is the 30-minute mark. Um, when I give this presentation live, like face to face audience, I'm always looking to see expressions. I'm always wondering who was mind blown that we're already seeing this much of effect in 30 minutes, or who kind of guessed that from the beginning. I'll tell you for myself, I was shocked at how fast this was. I thought this would be an overnight thing, not 30 minutes. So we'll check back in on that again. So now we'll talk about research and conservation. This is Dr. Jim Williams at University of Florida. He's retired now. He wrote the Mussels of Florida and he wrote the Mussels of Alabama. Those are two excellent texts. And he's just a super cool dude, very knowledgeable, full of fun stories. And he's done a lot in those southern drainages just to get people excited and teach them about mussels. On conservation, I don't know a lot about this. I haven't had any direct experience. I know it at a superficial level, but I just want to introduce that one of the novel techniques for conservation is propagation. So they'll actually go out in the field and they'll find gravid females. They'll bring them into the lab, put them in these tanks. You have to know the host fish and you have to be able to go get the host fish. The host fish are in the lab as well. There's a way to stimulate the Glaucidia release, and they'll collect those Glaucidia. They'll cycle them through this tank with the host fish. The host fish becomes infected, and you're just monitoring things, keeping everybody healthy for that period of time when those Glaucidia are developing. And then when they drop off, there's like a little filter in this tank setup that will collect those Glaucidia, and you move those to a grow out tank and continue to feed them. And when they're old enough that you can go release them into the wild, then you do. So this works. This is very effective, but you have to have the recipe just right. And unfortunately, like for so many of our species, especially the imperiled ones, like I said, we don't know the host fish. Like we can't go get one, or it might be difficult to sample, or it might be difficult to keep alive in a lab setting. The a lot of the research that happens with these at the university level is just trying to figure out what the host fish is. Let's just take the Glaucidia from this mussel and expose it to 30 different species of fish and see what it takes. You know, that happens, but then that raises a whole new set of questions because there's an artificial quality to that, and is this really what we're seeing in the wild? How much of this could be biased by the fact of just this setup? So you really don't have certainty until really what's good if you find a fish in the wild, bring it in, and if it's infected, and see what drops off and grows, but that takes a long time. On the research and on the conservation, it's a lot of survey work to go out there and see where these mussels are. Repeated measures, go back years later, are they still there? Are they still there in the same numbers? How's the growth, you know? And the tools for that I'll sort of go through on the next few slides, but oftentimes it's just a snorkel and a mask. Any water that's over arm deep, you kind of get out of snorkel territory because you need to go on the bottom and stay on the bottom. It's exhausting taking breaths and going down and porpoising up and down. So after about 3 feet, you need scuba. But these are like my favorite surveys when you've got nice clear water and it's shallow enough that you can snorkel most of it. These are really fun. Usually the water's clear in that setting, so you get a visual on the mussel. You do what they call tactile survey, so you're grubbing, but you're also looking. You're going to see them siphoning at the surface. We also scuba is more common. Anything deep. This was a bridge rebuild project on the Chipola River in Florida. This one was a little bit hairy. It was a big river. It was kind of deep. Really poor water quality, and we safety first. We had a lot of precautions in place, but we got a good survey. So when we do something like this where there's a bridge, we're surveying to see if they're there, these imperiled, and if they are, then we're moving them out of harm's way, and that's the relocation part. And that sort of bridges the gap between research and conservation. We're moving them somewhere else. And a part of that survey, a very important part, is to go identify that recipient area. It needs to also be of sufficient quality that if we put these guys there, they're going to do okay. So we usually survey that area too, and finding that same species in the recipient side is the best way to confirm, like, yeah, this is supporting for this species because we're finding them here. And it needs to be big enough that you're not going to overload it. On this survey, we found 2,000 mussels, over 2,000. Not all those were listed, but still is a lot. So you don't want to move those and then overcrowd some other area. But that's an important part. This is called a hookah setup. This is like scuba, and that you can go on the bottom and stay on the bottom. There's an air compressor here that's delivering air via hoses to a mouth regulator, just like with scuba. And as long as this thing is full of gas and the motor doesn't quit on you, you can stay underwater indefinitely. which is nice because when you got scuba, you got those tanks are heavy to lug around, and eventually they're out of air. You got to go get another tank, and so this is logistically a little bit simpler. But this was last month in Lake Chautauqua, um, or Chautauqua Lake. Uh, so most of you have never muscled before, and you never will. So I have a little video here to sort of give you a point of view. This is something I took with a GoPro at one of my Florida streams, and just give you a quick little taste of what it's like. Probably 8 feet of water in a reasonably clear creek. You got a lot of cypress knees, a lot of detritus sort of mixed in. It's a sandy bottom. This is a coastal plain stream. Actually, I want to pause it real quick. Out here, this is sort of the middle of the channel. You start to see what look like little mini sand dunes. They basically are. That's coarser sand. It's loose, usually a little bit unconsolidated, not very productive. In fact, it can just be kind of a desert. Um, what we're looking for stuff usually at toe of slope or closer to bank. It has a loamier texture, spongier. It's got a little bit more clay and finer silts in there, and that's a firmer, more stable substrate, and that's where they like to be most of the time. I can tell by looking at it that's good stuff, and it's first is visual. I thought there's one. I saw that one, so just pluck it right out. Put it in a little mesh bag. Keep going. Sometimes you don't see them. You just have to feel around for them. There's one. He's popping out of the sediment. So this is, you look at the rays on this one. This is I think the common name of this is little spectacle case. This is used to be the genus Velosa. They just moved it. It's Leaunio, um, lianosa. But this species, this whole genus, this species is sexually dimorphic, meaning that the male and the female can have different physical characteristics. So if muscles weren't hard enough, now the females look different than the males. But fortunately, usually what happens is, and this is a female, it's a lot more inflated up here at this posterior end, and that's just to make room inside the shell for reproduction for Glaucidia. And but overall, if you were to have this right next to a male, and I'm sure I have these pictures somewhere, but the female would be a more hatchet shaped, whereas the male would just be kind of more streamlined and elongate. Also, just again on the difficulties of ID, depending on where you are in a watershed, can affect the morphology or the I guess the overall appearance of the mussel. If you're way up in a headwater stretch of the Flint River or some tributary to it, and you find this one species, and then you go down, you're within 20 miles of the coast, and the river's really big and wide. It's got a completely different vibe, and that same species of mussel will look different. It'll be bigger, it'll be more inflated, it might be darker, and just another reason why these things are challenging. So we get them up out of the water. Kind of work quick. This was a nice cool day. It was overcast, so they weren't going to bake in the sun. So we immediately start sorting them on the bank. This part's tough when you're new, and kind of getting developing your proficiency, because it's easy to start second guessing yourself. You just dump these mesh bags, and it's just a big pile of everything that looks the same. And eventually, you start to get it, and you start to quickly cue in on those characteristics that will be unique to each species, and that's the sweet spot. Everybody gets to work, and you start grouping them by species. We'll take measurements of them at this time. Usually with a pair of calipers, we've taken a total length of the shell, but that's an indicator of growth when you come back and maybe get that one later. And that would be mark and recapture studies. So there's different ways to tag them. This is a nylon mollusk tag. We just put it on with super glue, and these stay on pretty well. This is the Chipola slab shell, federally threatened. And this is a PIT tag. Um, PIT, PIT is an acronym. It stands for passive uh, integrated transponder. And it's like a little glass capsule. It's about the size of a big grain of rice, and it's got some metal guts, and it emits a signal. It emits that signal is coded such that when you have a PIT tag reader, it'll flash like a 12, 13 digit number that's unique to that tag. There's different ways to affix them. Here we're putting this one on with dental cement, which has its pros and cons. It's expensive, but what I like about it is that it it has, in order to fully cure, it must be submerged in water. So you can kind of get these guys tagged and get them right back in the water. You're not waiting for some other sort of adhesive to dry. Um, One of the downsides, it's so bright white, so it just makes, it's like a shiny beacon on the shell. It makes it really conspicuous down there, and you know there are predators like a river otter might be able to spot this more readily than had you not tagged it. But this substance, whatever this dental cement, also accepts stain from the water. If it's tannic water, it doesn't take long to start getting tan and then brown and then darker brown. And here's a handful of tagged mussels. This has got a somewhat fresh pit tag on it. This pit tag's been on there for a while, and so you can see it's been absorbing those tannins, getting more and more stained. Here we've got a mollusk tag. This is my favorite species, by the way. This is the shiny rayed pocketbook, Hemiota subangulata. You know, you find this in those Gulf of Mexico drainages, and just to like paint the setting for you, you're in this dark tannic creek with cypress knees and water moccasins, and uh, oftentimes visibility is poor, and it might be soft muddy bottom, and you're sitting there and you feel this mussel coming out of the mud, and you pull it up, and this is exactly what it looks like. There is no brushing off the river funk. They come out shiny like it just got polished with those beautiful rays. It's like, wow, this came out of that. But um that's how it goes, and it's exciting when you get a really, these are just gorgeous mussels. It looks like a seashell that you'd find in a shell in a tourist shop. But although this one's a lot darker, you can see, so there's going to be variation. um, this is a pit tag reader, and you can kind of see the pit tag on this guy. There's the code. So if we tag this and we take a measurement of it, and we take it to the relocation site, and we go back 5 years later, and we find this mussel and we hit it with the reader, whoop, and it pops up that code, like we know that it's that same individual. We can learn if it's moved at all. We can track growth. um, the pit tag reader is also really good for just finding the mussels, because I think my next slide, these receivers, they have an underwater version. You scan it, it's like a metal detector. So you can walk, you can even swim with one in deeper water, and it'll make a little ping if you pass over one. And I could tell some really cool stories about that, but I'm gonna move ahead. Uh, this is cool. Side scan sonar. So this guy, Adam Kaiser, he works with Fish and Wildlife Service now in Panama City. But at the time when he was doing the methods testing for this, he was with the Georgia DNR, and he published this paper on using low cost side scan sonar. I don't know about low cost. It's the stuff that it's recreational grade, like you'd buy at Bass Pro Shop or Cabela's, but it's like top of the line. It's the Cadillac version there, so it's still a couple $3,000. But using that device to map benthic habitat, this is particularly useful for mussels. So in my previous job, I had one. This is the Aglockney River. Tallahassee is like right here. It's just outside of Tallahassee. And we ran, I don't know, about a 7 or 8 mile stretch of it and mapped it, had it mounted off the bow. And this was sort of typical, um, the output from that. Um, Basically the center line here, and there's a little, maybe a boat icon. This is the travel. This is your boat travel, and you've got imagery on the starboard and imagery on the port. And the way you have to interpret this is you kind of make a seam along that path of travel and fold it on that axis, and then look at it as sort of at a side view. Um, this yellow line, you can kind of see depth. So the channel is getting a little bit deeper. We're getting into a pool. You can see all these different textures and colorations to the substrate. These are microhabitats, and you can delineate these. You can see what you're dealing with. You can tell rock outcroppings, um, shifting loose coarse sand. You can see the woody debris. You can get a feel for steepness of the bank. Slope is often these mussels often like to be on slopes. Um, and this is on the left. You can see all those textures here where we've stitched together the imagery that we took with the side scan, and then here we actually went in and delineated various habitats that would be relevant to freshwater mussels. Um, just some more images here. What I like about this is you see the etching on the bank. So these are various water levels, and that's an indication of some steepness and slope here. But what you're seeing here, this is a bridge bent with each individual pylon casting its own sonar shadow. It's this. I'll go back, so it's kind of neat. We just drive by that, and that's what it looks like underwater. Let's see, what do we have here? So here we're coming out of a kind of a deeper section of river. It's getting a little bit shallow. Here's those sand dunes. That this is the shifting stuff that tends to not be very productive, and so it's nice to take this imagery and know like we don't need to spend a lot of time there. Up here, this is aquatic vegetation, like a bunch of like floating lilies and whatnot. Um, this is nightmarish. This is a massive pile of downed trees that, for whatever reason, have decided to accumulate in this section of the river. We did survey this portion of the river. The Aglockney River has got zero visibility. It's you put your hand in front of your face, you don't see it. You just close your eyes while you're down there surveying, just so you can better focus on feel. And you're in about, I don't know, 15 feet of water. The current's ripping, so you're having to negotiate flow. You can't see, and then you want to get tangled up in all this nastiness. This is dangerous. This is like game over material here, and yet from the surface you would never know this is what that looked like without the side scan sonar. So there's a health and safety aspect. You get to know what you're diving down on, um, and plan accordingly. It's like, guys, we're not going to get tangled up in this, so let's just stay away from that. That was actually the bridge that we were surveying for, because they had to do some work on it. This is my favorite. Well, first of all, you see the etching along the bank. You see a lot of woody debris. These are down trees, and you see this guy, a large body something, casting a sonar shadow and kicking up a plume of sediment on the bottom. I don't know if anybody has any guesses on what that is. It's Florida. that's the we we learned what that gator signature looked like, and I will say that I've definitely been sketched out a few times, but I've never had a close call. Um, Water moccasins either. It's this this is one of the last slides, so we're kind of bringing up to the end here. But this is the lower Apalachicola River. It gets really wide, not too far from the coast, and we had to do several passes and stitch that together. But we were able to delineate the habitats and create this stratified random sampling design where we were stratifying according to the different substrate types to make sure that we hit everything and in the right proportions. So it's cool that we could use that technology to inform the study design. This one was weird because we found like an F-150 submerged in about 15 feet of water, like right here. This is a boat launch. And that was creepy, going up to the window and like, looking in and wondering if you're going to see remains. But fortunately, it was empty cab. Just some people joyriding. We recorded the VIN and reported it to the cops. Um, we found a lot of the purple bank climber mussel along this bank, which is cool. That's a federally threatened species. And yeah. So back to our kidneys of the stream. This is it at 2 hours. I mean, this is spectacular. You know, what a stark example of the service, one of the services that they're providing, and also a stark reminder of the service that's lost when we lose these mussels. You know, you could read a newspaper through that. So, with that, I have my email here if anybody ever wanted to reach out to me with a question offline or ask me for a, a picture or one of these slides, whatever. And yeah, I drug that out a little bit longer. So there's like 10 minutes left or so for if there are any questions, happy to entertain them. Thank you for your attention.
That was fantastic, Jason. Really fascinating. If you stop screen sharing and people can unmute themselves, and then I'm sure there'll be some questions. And actually, I have one just off the top of my head. Seek, the new building that Ecos is a partner in at the lake in Schenectady, like what is likely to be in that urban polluted lake as far as mussels?
You'd be surprised. There could be some in there. I doubt it because it's mostly a stormwater management sort of thing. But if you put mussels in there, they would survive. And if there had not been mussels in there naturally, they could have found their way there with fish. Maybe a bird picked a fish up, flew across, dropped it, or a fisherman could have had live fish bait, and those bait fish could have been infected with glaucoma. You see that? Um, the really common hardy species that I find just about in every lake in New York. It's the genus is Elliptio, and they're just very common. It's a big bodied species, and it depends. That there's species. There's a genus called Uniamorus that can actually survive desiccation. I have been in stream beds where you can kick up dirt because there's no water, and I found just a whole bunch of dead shells, and I picked one up, and it was really heavy, and I couldn't open it, and I thought surely this is dead. Maybe it's just suction close because of mud, and I took it back to my office and I put it in my fish tank, and the next day it's opened up and it's siphoning. So
Oh,
yeah, some of these things can live in dry dirt. Some of these can live in really crappy farm ponds, cattle watering ponds, and some mussels just thrive in that. So I
wow.
don't know if there'd be any in that lake or not, but would be cool to put some in there and let them do their good.
Really would. What a great project.
Yeah, there's definitely carp in there.
I bet there are mussels in there. Like I wouldn't be surprised a bit. Um,
Sounds like a scary river center project.
but the next time, if you ever go to any of our area lakes, whether it's Round Lake or Saratoga or Moreau, if you're swimming in the swimming area, you'll find the mussels there. Try it, go down and grub the mud a little bit. It won't take you long before you're like, oh, what's this? And then you bring it up out. And,
Wow.
I do that all the time because I just like can't help myself. But
Well, I gotta admit, like it sounds fascinating and fun, except for the alligator and water moccasin part.
yeah,
But,
yeah. All these streams are the same. You pull up to start the survey and you're standing at the bridge. You're like, I do not want to get into this. But then not long after you have gotten into it, you just sort of acclimate, and then you start to see it from a different perspective, and it's less sketchy, and you just sort of sometimes it's less sketchy, sometimes it's not. But
oh, I love that underwater Easter egg hunt enthusiasm that
yeah, that's the vibe. It's fun.
so some questions?
This isn't really related to muscles, but I had a question about one of your slides.
Sure. Hey, Benet,
Yeah,
good to see you, man.
yeah, hi, thanks for it. Yeah, it's a great presentation. What is the difference between the abbreviation SP and SPP? Are they both species or do they mean different
Yeah.
things?
So if I had both, and that might have been a typo, but SP 1P is
Uh-huh.
species singular, and SPP would be multiple. The word
Oh, okay, great.
species can be singular or plural, but that's the way. So if I'm saying 32 SPP, that's just because there's 32 species, multiple
Okay,
species.
sure, thanks. Yeah, I never knew
Yeah,
that.
sure.
Huh?
I was actually curious, how long can mussels stay out of the water? Because, there were a lot of pictures where you had them on the bank, as you were doing your survey, and I was just kind of wondering, if there's a period of time that you're like, okay, back in the water you go.
Yeah, that's a great question. It kind of depends on so it depends on a number of factors. And I don't know if there's like a threshold, like hour level that I could give you. Um, I know when we're relocating them, the advised way to relocate them is not to keep them submerged in water, but rather to put them in a cooler and just put like a wet towel over the top. When they're in water, they're going to try to respirate. And as they're consuming all the oxygen, they're going to start having to work harder and harder for it. And they're depleting it. And they're just burning calories. And there's not a lot of margin. They don't, they need all those, they need all that energy. And so when you just put them under a wet rag, they're just going to stay closed. The biggest thing is to keep them out of the heat. Heat stress would be the biggest killer. So if it's a bright sunny day and we're getting beat down on by this, we're not going to have them out on the bank like that. Or if we do, it's not going to be for long. That particular survey, we were all freezing our butts off because it was January. I mean, it's Florida, but still it's cold. It was a January. It might have been October. Still, it was cold. It was overcast. There was very little concern of heat stress. I don't know if that fully answered your
No,
question.
it does. Thank you.
So what are they doing up north of us in Canada during the winter? They're down there under the ice, just
Yeah,
filtering away and
yeah, yeah. They have the ability to bury. Um, I'll share you one. I'll share a quick anecdote with the pit tag reader. On one of my surveys, we were at the end of the day, and this the pit tag reader was out of battery, so we tagged a mussel, but we couldn't record what the 13-digit code was. We didn't know, so I laid it down, sort of embedded it in the sediment, and I had 3 fishing weights with flagging tape to sort of triangulate where it was, and the next morning we go, and now I've got fresh batteries in my reader, and the very first thing I do is go to that area. I'm feeling around. There's my fishing weights, but there's no mussel. And I'm like, where'd it go? I get the pit tag reader. Bleep. I'm like, well, okay, it's here. So I start digging deeper. Still not there. I'm like, I don't know. Bleep. And I'm starting to think maybe he shed the tag. And this is not making sense. And I just kept digging deeper, and I finally found him, and he was elbow deep
wow.
buried. That was just overnight, and it's not like a cold front came through. There was really no reason, and nothing was different about the river condition. But that just goes to show you that they can and they do have that vertical migration. I think in the wintertime, that's also a mechanism to stay a little bit warmer, perhaps.
Wow, amazing. Well, I kind of wonder how I went through life not knowing some of this stuff. I had no idea about the fish host and things, but I'm hoping I'm going to talk to you about incorporating some little piece of this into our Connecting Kids with Nature programs.
Yeah, it would
Get
be
together
cool.
with you and see what kind of little hands-on, even if it's just having mussels there and something to identify them.
Yeah, I'll have to start. I'll start chewing away on that and see what I can think of. I'd love to get kids interested and knowledgeable about these. It's very underrepresented at just about every museum and even aquariums. It's just like
Yeah.
they have like a little placard for mussels. That's it. It's like, come on, you guys could do so much more.
Well, oh, you kind of said it when you said there's no charisma in my hand, so we
Yeah,
gotta.
yeah. There's
But
that.
so important.
Hey, Jason.
Hey, Chris.
Hey, are there any bodies of water or rivers that have any endangered ones around us?
Yeah. Um, there are. I should have put a slide or two in about New York mussels. There's state protected, and those are more common. The only federal listed in this part of New York is it's called the dwarf wedge mussel. It's a little guy, and it's found in a few spots in Orange County.
Okay.
It's one of those species that is generally rare, but where found can be locally abundant. And so we have a couple of those little hot spots here. Yeah, that's federally endangered.
Hello,
And when you go to
Jason.
Western New York, you pick up some more. Yeah, sorry. Yeah, go ahead.
Are these the mussels that they made buttons with years
Yeah.
ago?
Yes. Yeah.
Okay.
I didn't talk at all for the reasons of their decline. I just said that they're declining. The biggest reason is habitat loss, but also overfishing. They were used, those big bodied mussels they would punch out those buttons, and yeah, that's absolutely.
Hmm.
And even now, when the buttons are made out of plastic, but they're made to have that pearlescent look to them because
Hmm.
they're mimicking that, Yeah. They also, even now, still will harvest these mussels commercially to make little blanks for freshwater grown pearls. The nacre, the really shiny, beautiful stuff on the inside, they can just take a little bit of that and plant it into an oyster and cultivate a pearl from it.
So when you talk about habitat loss, I mean, usually we think of things that are not in the water with habitat loss to development. But in this case, of course, the water is always still there. It's just the degradation, the
Yeah,
pollutant.
poor, all the above. Poor land use practice. When you like um, when you have a lot of bad erosion throughout your watershed, and it rains and you see that chocolate milk, that turbid water flowing down the street gutter, that's going into a creek. And when it gets into the creek, eventually the velocity is going to slow down and let those particles start to settle out. And when you walk across what should have been a rocky bottom and instead you're ankle deep in mud, that smothers that all that's left are the generalist species that can survive in a stormwater ditch, and everything else that had any kind of sensitivity is gone. So we see that on a grand scale in just about every watershed in North America. It's sad.
Yeah. Any other questions? Well, this was really interesting. Thank you, Jason. I'm looking forward to getting this information out. ECOS, getting that into some of our programs with kids and parents and toddlers. So next month on the third Thursday at 7 o'clock is going to be all about water and sewer. And I told her she could do it like the 8th grade level because most of us don't know much about that. It's like magic. And when she came out with her talk title, she apparently accommodated me there. And she called it From Faucet to Flush. So we'll be learning all about that in November. Take a break in December and be back with more speakers in January. So check the website from your MailChimps for that. So thanks again, Jason. That was just great.
Well, thanks y'all for listening.
Loved it.
Thank you.
Thank
Great.
you.
Night.
See ya.
Bye.